All right, next up here, we'll go ahead and do number 5. So the first thing I want to track is what's the common difference here. So I see that this is consistent minus 4. So that'll be my common difference here is negative 4. Next thing, since I'm going to use this version of the formula over here, I need to find out what's a sub 0. Now a sub 0 is always, hypothetically, what's the term in front of the first term. We know that the first term here, a sub 1, is 9. And so if there was another term in front of that, I would have to add 4 to get to it, so that would be 13. You can see that 13 would kind of follow that same pattern. So I'm going to say a sub 0 is 13. And so now we can do our formula, a sub n equals negative 4n plus 13. So then it asks me for a sub 22. So for that, I'm just going to plug in a 22 for n. And so a sub 22 would be negative 88 plus 13 would be negative 75. All right, next up, same idea here. This pattern actually looks like a plus 6 pattern. So we'll have a positive common difference, positive 6. And then our a sub 0 back here, hypothetically. So we're adding 6 going right, which means we're subtracting 6 going left. So I would have to have a negative 21 there to fit the pattern. And so with my a sub 0 at negative 21, I can just write my formula as a sub n equals 6n minus 21. You can always see, which is always a good idea. I always kind of like plug in a 1 right here and see if I get that first term. So 6 times 1, so 6 minus 21 does give me negative 15. So your formula should accurately predict the first term, second term, third term, and fourth term. Okay, so now they want a sub 22 again. So I'll just go ahead and plug in a 22 here for n. And so that'll be 111. Okay, now they're going to kind of start giving us some different information here, so we can still use that to write our formula. So in this case, they tell me the common difference is 5, and so I can write this as a sub n equals 5n plus a sub 0. But they did not tell me a sub 0, and I don't have like the list where I could figure that out. So what I would do here is I would take this, and I kind of think of this like a point. So I can plug in 11 for n. And it says that when I plug in 11 for n, I should get 41 out here for a sub 11. So it's kind of like this is your x. I would think of it 11 comma 41. It's like when I plug in 41 as for x, I get out 41 for y. Okay, so I can go ahead and just solve this. So I get 55 plus a sub 0 equals 41. I could subtract that 55 over. And I get a sub 0 equals negative 14. So I would say a sub n equals 5n minus 14. If you wanted to check that, you could go ahead and plug in, I can actually do that in my head. So I plug in 11 for n, so 5 times 11, 55 minus 14. You can see that that does give us 41. All right, next up here, they actually give us two terms. They give us a sub 10 and a sub 20. So for this, I would once again think of these as points. So we have 10 comma 22. And then 20 comma 37. So the subscript is like your x value, and then what it equals is like your y value. So they don't tell me the common difference here, but we need to remember what I said at the top here, which was that the common difference is really like the slope. And so if we want to do the slope, we can always do y2 minus y1 over x2 minus x1. So that applies here as well. Okay, so for this one, I'll do 37 minus 22 over 20 minus 10. So that would be 15 over 10. Which you could do is 3 over 2 or 1.5, either way. Okay, so we finally have our common difference, but we still don't have a sub 0. So we're going to have to find a sub 0 now, and that's kind of the same way we did before. So we're going to say a sub n equals let's go 3 over 2, I'll call it. You could use 1.5 as well. And then this will be n plus a sub 0. And I'll just use one of these 2 points. I'll go ahead and use that one since it has a smaller number. So I'm going to plug in 22 for the y. I'll plug in 10 for the x or the n. And I'll find out what a sub 0 is. So we can cross cancel there. Remember, we don't need common denominator to multiply fractions. So we get 15 plus a sub 0. I'll just subtract the 15 over. So a sub 0 would equal 7. So my final answer here for the formula would be a sub n equals 3 over 2 or 1.5n plus 7. Once again there, if you ever wanted to check, we could plug in one of our points. So if I plugged in 20 here, so 3 over 2 times 20 plus 7 would give me 37. Okay, so same idea here for practice 3. So a sub n equals negative 12n plus some a sub 0 that I don't know. We'll go ahead and plug in the 107 here up front. And then, oops, I got to plug in 15 for n. Negative 12 times 15, it's 180, so 107 equals negative 180 plus a sub 0. So I mean, if I add the 180 over, a sub 0 would have to be 287. So we can say a sub n equals negative 12n plus 287. This one also asks for a sub 22, so we'll go ahead and plug in a 22 there. And that one comes out a sub 22 equals 23. All right, next up here, this is another one where they don't give us the common difference, so it's like finding the slope, remember. So I'm just going to do y2 minus y1 over x2 minus x1. Remember, you need to subtract those the denominators in the same order. So 10 goes with 60, you can see here, and then 15 goes with 5. Okay, so we'll just call that 55 over negative 5, so that's going to be a negative 11. So we're going to say a sub n equals negative 11n plus some a sub 0, which I don't know. And then I'll go ahead and say, I'm actually going to use this point because the x value is smaller. It doesn't matter though, you could use either point if you wanted to. So negative 110 plus a sub 0 equals 60. And then so we add over the 110 and 170 equals a sub 0. So my formula here would be a sub n equals negative 11n plus 170. And then a sub 22. So then if we want a sub 22, we're just going to do negative 11 times 22 plus 170. So that's going to be negative 72. All right, now we're going to work on the sum of an arithmetic series, aka the partial sum. So there's a couple formulas for this that we'll learn that are interchangeable, but I kind of like to tell this Carl Gauss story because it's fun. So the Carl Gauss story goes as follows. So Carl Gauss was a kindergartner, and his teacher asked him, or he was annoying his teacher, so his teacher asked him to add up all the numbers between 1 and 100. And so Carl Gauss went to the back of the room to add up all the numbers between 1 and 100. You can see that she asked him this question, and in about 15 seconds he came back and sat down in his seat. His teacher said, "Hey Carl, you're supposed to add up all the numbers between 1 and 100. He said, "I did. It's 5,050. And his teacher said, "What?" And he said, "The sum of all the numbers between 1 and 100 is 5,050. His teacher didn't know the answer to this question, so she went and sat down and added all of them up by hand and found out that he was correct. Now, did Carl Gauss actually add the numbers? No, he didn't. Let me show you what Carl Gauss did. He connected the 100 and the 1 and realized if you add those together, it's 101. And then if you add 2 plus 99, it's 101 again. And if you add 3 and 98, it's 101 again. And so he realized that he just has these pairs of 101, and he realized he had 50 pairs of 100, a sum of 101. So he knew he could multiply that and just get 5,050. Okay? So that leads us to our formula here. So we have n is the number of terms that we're adding. And then a sub 1 would be the first term in the list. and then a sub n would be the last term in the list, and then we're going to divide that by 2. Okay? I put the or here. The other version of the formula is if you just say n over 2 times a sub 1 plus a sub n, that'll also work. So we're just dividing by 2. You can kind of decide if you're going to do it on the inside here or outside here. This one is actually the one Carl Gauss did. You can see he added up the first term and the last term. That's what gave him the 101. And then the number of terms is 100, so he cut that in half because he was pairing them up, and that gave him the 50. I also like this term because it's saying I see this as you're taking the average of these two terms. You see that? The first term plus the last term divided by 2. That's really the average. And then multiplying that by the number of numbers. So however you want to look at it, okay? Okay, so when we get these problems down here, and I actually want to do number 10 first. Let's go ahead and do that. So for number 10, instead of plugging in all the numbers between 1 and 18, I actually only need to plug in the first number and the last number. So I need to know a sub 1 is 77 minus 4 times 1, so obviously that's 73. And then a sub 18, 77 minus 4 times 18. You get that. It's 5. And I know my number of terms here is 18, because I'm going from the first term to the 18th term. So I can just do my formula here. I'm going to do 18 over 2 times 73 plus 5. So that's really 9 times 78, right? And so that gives me 702 for the sum there, okay? So we didn't have to plug in all the numbers between 1 and 18. We just had to plug in the first one and the last one, okay? So I'm going to do that now for number 9. So for number 9, I'm just going to do a sub 3. You can see in this case, a sub 1 is actually not really a sub 1. We're actually starting with the third term. So it's just whatever term you're starting with. So even though the formula says a sub 1, it's really just plug in the number on bottom first for these sigmas. So that gives me 5. A sub 56 is 3 times 56 minus 4. So that's going to give me 164. Now the tough one here is n, okay? So for n on this one, most people would think it's 53. I'm actually going to tell you that it's 54, okay? So here's how you can always find n on a sigma. You can do the top number minus the bottom number plus 1. You need to add 1 in there because when you're doing subtracting, it doesn't really include the number you're starting with. So since we're including both, we need to add that 1 back there, okay? So that's where I'm getting 54 from. I get 56 minus 3 plus 1 would give me the 54. It actually does work for this one as well, right? So we did 18 minus 1. That would give us 17, but we have to add the 1 back, okay? Okay, so now we'll go ahead and do our formula. So we get S equals, I'm going to go 54 over 2 times the first number plus the last number. Okay, so let's just type that in the calculator now. So S equals 4563. All right, so here we're going to use our formula some more. Okay, so awesome. So we know our sum then, as we learned on the previous page, is n over 2 times the first number plus the last number, right? So you can see on both of these, we actually know the first number and the last number. We know that we're starting with 3 and we're ending with 159. What we don't know is n, the number of numbers, right? So whenever on these you're missing a piece of information, I would go ahead and write down I would use our explicit formula to figure it out. So we're going to go back now to our explicit formula. So I'm going to have to know the common difference here we see is 4. I'm going to backtrack and I could see a sub 0 would be negative 1, right? And so I'm going to say a sub n equals 4n minus 1. So I'm going to write that down, and this is going to help me figure out n because I'm going to plug in 159 out front, and that's going to allow me to solve for, well, what is n? So I'm going to add this 1 over, so we get 4n equals 160 divided by 4. And so n equals 40. So we know then, according to that, that 159 is the 40th term. So that gives me that n to plug in there. From there, I can just type that in the calculator now. So we can do 20 parentheses 3 plus 159. And so that sum is going to be 3240. All right, so same idea on this one. So we already know that our first term is 8.2, and our last term is a negative 46.8, so I'm just going to put minus 46.8. But we need to know what n is. So I'm going to have to write my formula. I see that my common difference is actually negative 1.1. And so if I added 1.1 going the other way, my a sub 0 would be 9.3. So I could say a sub n equals negative 1.1n plus 9.3. Okay, and now I'm going to use that to plug in negative 46.8 to figure out what number term it is. I'm going to subtract my 9.3 over, so negative 46.8 minus 9.3. It's going to give me negative 56.1 plus negative 1.1n. And so divide that by negative 1.1, and n is going to be 51. All right, so I can type that in the calculator. 51 divided by 2, parentheses, 8.2 minus 46.8. And so I get the sum is negative 984.3. Does it make sense that that's a decimal? I would say yes. We're adding up a bunch of decimals, so there's definitely a chance it's a decimal. It's definitely probably going to be a decimal. It is possible to add up a bunch of decimals and get a whole number, right? But unlikely, I would say. Does it make sense that it's negative? I would also say yes. You can see that the sequence here is going to get negative pretty soon here, and since we have 51 terms, we're going to have a lot more negative terms than positive terms, so the negatives are going to kind of outweigh the positives. All right, next question here. We can apply this sequences in series to stacking logs. So logs are stacked on top of each other. The bottom row has 21, the top row has 15. Each row has one less log than the row below. So it looks like this sequence would go something like 21, 20, ... Depending on how you interpreted which is the first row, I would say the bottom row is the first row. If you said the top row is the first row, I could actually understand that. I'm going to say, though, it's the bottom row, okay? So we can see here our common difference is minus 1. We know our kind of hypothetical term in front of the first term would be 22. So I'm going to say a sub n equals negative 1n plus 22. You can see that when I plug in a 1 there, it's going to give me 21 and so on. How many rows are in the pile? Well, I could take that. I could plug in 15 right here, since we know that's our top row, and then subtract the 22 over. And so negative n equals negative 7. So that would mean n equals 7. So there's 7 rows in the pile. How many logs are in the pile? So that would be our sum formula, right? So we know that we have 7 rows, and we know that the first one is the first one's 22, and then the last one's 15. Oh no, the first one's not 22. The first one's 21. Excuse me. 126. Yeah, I was already thinking if that was 22 in there, that would have come out to a decimal, and it doesn't make sense for us to have like half of a log, right? Because we're going to have 126 logs. All right, next up here, it says you enter a taxi that charges an initial fee of $2. You watch it go up. After 1 mile, it's $3.50. 2 miles is $5. 3 miles is $1.50. So it seems to me that the common difference is 150. So each time we go another mile, it increases by 1.5. And then I'm going to say actually a sub 0 is $2 because I already owe $2 when I've gone 0 miles, right? So I'm going to say a sub n equals 1.5n plus 2. You can see if I plug in 1, I do get that 350 and so on. What's the total cost for 13 miles? I'm actually going to say that this is not a sum. This is just a sub 13. If you can kind of see how this question is worded, at each step there, it's the a sub n is giving you the total cost, okay? So it's adding all that up for you. So in this case, it's just a sub 13. I'm just going to plug that in and get my answer here. So 1.5 times 13 plus 2, and that's going to give me 21.5.